Hi everyone, and welcome back to another video. So I'm Michael, and I'll be explaining problem number 1 on the Washington Gold HMMT PUMaC team selection test. So in this problem, we're given this region spanned by 8 points, and we just want to find its area. So at first sight, this region doesn't look especially friendly because it's not a triangle, it's not a quadrilateral, it's not something we can easily compute the areas of. And so when we have a weird region like this, often the key step is just to split it up into regions we know how to calculate the areas of. And in this particular case, we can see that this is actually not too bad. So if we zoom in here, we can see that we can split this region into 3 smaller regions. So the first region, I'm going to outline this in red. It's just this region here, spanned by these 2 triangles. So this triangle and this triangle. So these 2 triangles, and let's call this region region 1. So this region is going to equal region 1. And now we can just keep doing this. So if we switch to another color, we can see that we can also split the area into these regions. These 2 triangles, let's say they form another region. So this, let's call this one region 2. Region 2. And well, now the last one is clear. Let's switch to this green color, same color as the region, and let's outline these 2 triangles. So we have our last 2 triangles here. Last 2 triangles, and let's call this region 3. So the green is going to be region 3. Great. So now all that remains is to calculate the areas of each of the individual regions, because you can just see the areas of each of the individual regions is just going to be a triangle, 2 triangles smushed together. So let's try to calculate the area of region 1. So I'm just going to erase all the other regions to give ourselves some more room to work with temporarily. So if you remember, this is region 1. And what does region 1 say? So region 1 is comprised of these 2 triangles. And the area of a triangle is base times height, so we need to find its base. And in order to find the length of its base, we need to calculate the length of this side right here, which means that we need to calculate the intersection point of this line connecting 0, 0, and 1, 2 with this line connecting negative 2, 1, and 2, 1. So let's do that. So this point, so the line connecting 0, 0, and 1, 2 is given by y equals 2x. And this horizontal line here, well, this is just given by y equals 1. Which means that this intersection point is going to be 1/2, 1. And this point is 0, 1, so that means the length of the base of this triangle is 1/2. And so that's good, we got the base. So what's the height of this triangle? Well, the height of this triangle is just the distance from 1, 2 to the line, well, the line y equals 1. So since the y coordinate of this point is 2, this distance, the height, is just 1. So that means the total area of this triangle is equal to 1/2 times the base times the height. But since there are 2 triangles here, we know that the total area of region 1 is just equal to the base times the height, which is 1/2 times 1, so it is equal to 1/2. Great. So we got the area of region 1. Now let's turn our attention to region 2. Actually, region 2 is really straightforward because we don't even have to compute anything. We can just see that the region 2 is the combination of the areas of this right triangle and this right triangle. And as before, we only need to multiply the base times the height of one of these right triangles to get the whole region. So the base is, let's make the base this line. And since this is 0, 0, and this is 0, 1, the base just has a length of 1. And the height is going to be from negative 2, comma 1 to 0, comma 1. So the height is going to have a length of 2. So that means the total area of region 2, like region 1, is going to be the base times the height. So it equals 2. Great. On to region 3. On to region 3. So like with region 1, for region 3, we're going to have to compute another intersection point. So we can see that region 3 is going to be the combined area of these two triangles. So we want to find this intersection point to get the area of one of these triangles, and then we can just multiply its base by its height to get the entire area of the region. So what is that intersection point? What is this intersection point? Well, this intersection point is the point of intersection between the line connecting 0, 0 and 2, 1 with the line connecting 0, 1 and 3, 0. And we can find the equations of these lines. So the equation of this line here is going to be y equals 1/2 x. And the equation of the line connecting 0, 1 and 3, 0 is going to be equal to y equals negative 1/3 times x plus 1. And to calculate the intersection of these two lines, we can just solve for when these are equal. So we want 1/2 x equals negative 1/3 x plus 1. So 1/2 plus 1/3 x is going to be equal to 1. 1/2 plus 1/3 equals 5/6. 5/6 x is equal to 1. So that means x is equal to 6 over 5. And plugging this in, we can see that the intersection point is 6 over 5, comma 3 over 5. Cool. So that means the height of this triangle, since the base of this triangle, we already know that's length 3, right? Because that's just from 0, 0 to 3, 0. The height of this triangle is going to be the y coordinate of the point of intersection. So we know that the height is equal to 3 divided by 5. So the total region of the total area of region 3 is going to be the base times the height, 3 times 3/5. So it's going to equal 9/5. Cool. Let's clear this space because now we're ready for the final addition. Great. So what is the total area of the region? It's just going to be the sum of these three. And let's add this. 1/2 plus 2. 1/2 plus 2 equals 5 over 2. And adding on the area of region 3. 5 over 2 plus 9 over 5. Well, that's just, let's see, 25 over 10 plus 18 over 10. And when we add these, this is 43 over 10, or 4.3. And we're done.